In this part, I will discuss the acceleration occurred in the circular motion. As we discussed previously, that the direction of the velocity in the circular motion is the tangent of the circle, meaning that the direction of the velocity is always perpendicular to the radius of the circle. Therefore, the direction is always changes at different position. Velocity of an object moves in the circular motion is a vector quantity. So when the direction of the velocity changes, the velocity also changes, although its magnitude is constant in this case. The changing velocity is related to the acceleration. So there is an acceleration in the uniform circular motion, and this acceleration is due to the changing direction of the velocity. We call the acceleration in the uniform circular motion as the centripetal acceleration, meaning that the direction of the centripetal acceleration is always pointing to the center of the circle. So this is the centripetal acceleration. Also this one pointing to the center. So if the object is at this position, therefore this is the direction of the centripetal acceleration. So here you will see that the direction of the centripetal acceleration and the direction of the linear velocity v is always perpendicular. For example, if the object is at this location, this is the centripetal acceleration and this is the linear velocity, and they are perpendicular because the centripetal acceleration is pointing to the center and the linear velocity v is perpendicular to the radius of the circle. There are some derivation of the magnitude of the centripetal acceleration that you can see from the physics textbook. However, in this part I will go directly to the magnitude of the centripetal acceleration. But you must know that the centripetal acceleration depends on the radius of the circle r and also the linear velocity v. Therefore, the magnitude of the centripetal acceleration is equal to the square of the linear velocity v divided by the radius of the circle r. Or, as you know that the linear velocity v is equal to the angular velocity omega times r, therefore the centripetal acceleration will be omega times r square divided by r. So you get the centripetal acceleration will be omega square times r. Well, you can use this one, omega square times r, or v square divided by r. So now let's see the first example. Here we have an object moving in the circular path, and it does 20 revolutions per minute, or we often say RPM, and the radius of the circle here is 2 meters. Let's find the angular velocity omega and the linear velocity v and the centripetal acceleration here. Now, first we should find the period of the motion. See, we have 20 revolutions in 1 minute, or we can say 20 revolutions in 60 seconds. Therefore, in one revolution it will take 3 seconds, and you have learned that the time of the object to move to complete one circle is the period. So this 3 seconds is the period of the motion. And since we have calculated the period, we can calculate now the angular velocity omega, and it's 2 pi divided by period. Here you can calculate that the value of omega will be 2.093 radian per second. Here 3.14 is the value of pi. And after we find the angular velocity omega, we can find the value of the linear velocity v. As you know that the linear velocity v is omega times r, so here the omega is 2.093 radian per second times the radius 2 meter, and we get 4.186 meter per second. That's the linear velocity v. And now we can calculate the centripetal acceleration, and as you know, the value is the v squared divided by the radius, so you get 4.168 squared divided by 2. Therefore we get 8.76 meter per second square. Let's now go back to our Earth example. So we know that the period of the rotation of the Earth is 24 hours. Therefore, if you calculate the angular velocity omega, it will be 7.27 times 10 to the minus 5 radian per second. And the radius of the Earth is 6,378.1 kilometers. So if you are standing on the equator, you will have the linear velocity as omega times r, and you get, if you plug this number and this number, we get 0.4638 kilometer per second, or you get 463.8 meters per second. And if you have a friend who is standing on the other location on the earth, he will have different value of the velocity v. So now you will also have the centripetal acceleration, and the value will be this number square divided by the radius. And we get 0.0337 meter per second square. And this value is very small actually compared to the value of the acceleration due to gravity. It's around 9.8 meter per second. So in our discussion, we will limit ourselves up to this point, and I will discuss the force related to the circular motion after we discuss the topic of Newton's law.